Good morning to everybody, and it's a pleasure for me to introduce to you the keynote of Professor Henning Meschede. And Henning is Professor of Energy System and Technology at the Paderborn University. His research topic focused mainly on renewable energies. He has a lot of experience in this way around many research places in Europe, and it will be a pleasure for me to invite him to have his keynote. The keynote will be about 35 minutes, and then we could open a little debate on his dissertation. If you have questions, you are invited to give him. So please, Henning, come here, and let's start your speech.
Yes, thank you very much for this kind introduction, and welcome everybody after having such a good social event yesterday. And before I start, I mean, the conference is almost done, so I don't want to close the conference, but until now it was a really good conference. I saw many good presentations, and yes, I'm very interested in the last day as well, and thanks to all the organizers for hosting this conference every year. Okay, so my talk today is about integrated renewable energy systems as the basis for sustainable industry and businesses. So you see we are talking a little bit more about industry and business, but the underlying methodology is also, or could be also used for other integrated energy systems. And before I start to talk about renewable energy systems, I want to introduce to you Paderborn, so the region where we are from. Because I think most of you haven't heard Paderborn or haven't seen Paderborn and have no idea how Paderborn looks, so don't be afraid, it's not a marketing presentation right now, because this is how we look at Paderborn. So you see wind turbines, you see agricultural land there, and that's Paderborn. There's also a city, but if you look around, you see wind turbines, a lot of wind turbines. So I can show you a lot of photos right now, and then 35 minutes will be over, and we just see wind turbines, but you all have seen wind turbines a lot. So let's switch to a map that makes it a little easier for us. You see, does it work? Yes. I hope you can see it on the left and on the right side. This is the city of Paderborn, surrounded by small villages, and especially in the south and in the east of Paderborn we have a lot of wind turbines. By the way, if you want to visit us, we are somewhere there in Germany. So we are not a coastal region, yeah? Usually at the coast in Germany or in Denmark we find a lot of wind turbines, but we are somehow about, I think, 200 kilometers, 250 kilometers away from the coast. So it's not a coastal area, but we have these wind turbines. And we, in addition to wind turbines, we also have PV systems. A lot of PV systems placed on the roof, ground-mounted systems, and so on. And of course, as you have seen already on the first slide, we have some agricultural land. So we also have some biogas and biomass plants that are the little green dots on the slides. So we have a lot of renewable energy right in there in Paderborn, and the discussion was always, are we on the track or not? I would guess, yeah, maybe Paderborn, yes, but Paderborn is not complete Europe. So, but I want to show you a few figures. Unfortunately, the web pages are in German, but I guess you can find the most important figures here. I will start with that one. The most important figure is that is the share of renewables on an annual basis, so about 160% renewable share in the power sector. So I would say, let's call it on track. Yeah, I see you agree, that's good. But we have some other sectors, like mobility, heating sector, there we have a lot to do. You see that there is a big share of wind power in this, at that time. It's almost 2 weeks ago. I figure out the numbers for today, so the most recent numbers is we have about 60% renewables in our power system in Paderborn, of which the most comes from PV. So at this time there's no wind blowing, but the sun is shining in Germany as well, and we have 60% renewables in the power sector, so you need see that we need this balancing and more than just one technology. And then you see in the other page a ranking. That's a competition, a contest between German cities. They want to figure out which city can build the most new build PV capacity, and rank 1 is at that moment Paderborn. Yeah, and that's enough marketing for Paderborn. So if you want to see it, just visit us. We are happy to show it to you. But let's come back to this page or to this map, because I mentioned we have the renewables in the system, and now we can decarbonize our power sector, but there's another thing in Paderborn which is very important. We have a lot of industry there. So that makes it different to coastal regions in Germany where we have not that much industry, sorry to say that. But in Paderborn you find industry, and for example, I guess you know Heidelberg Cement or Heidelberg Materials, so there's a cement producer there, a very energy intensive industry. Benteler Steel Tube, they do not produce steel, but they process steel, yeah, let's call it a cylinder, to make the tubes, so they need a lot of heat to run their processes. And we have some others. You see Paderborner, that's the name of the brewery, so usually in Germany we just call the breweries like the city. When you're in Paderborn, the beer name is Paderborner. Not the best one in Germany. But anyway, they need heat to run their processes as well. Stute, they cook marmalade and make juices and so on and so on. So we can think about the heat that they use, and I just roughly want to split that into few heat temperature levels. Heidelberg Cement, Benteler Steel Tube, they need high temperature heat. So they really have to glow the steel cylinders, they have to burn the clinker and so on. Whereas Stute, Paderborner, they need low to medium temperature, so you will not cook your marmalade with 1000 degrees Celsius, but something between 100 and 150, I guess. And then there are some other industries like Benteler Automotive, Class, they produce the harvesters. They may, the majority of their energy use is electricity to run the manufacturing lines. So, but you see we have different temperature needs. And now, if we want to figure out how to decarbonize the industry, we have to think, what are the energy needs? So if we want to supply industry with renewables, you start with the needs and figure out what do they need. Do they need electricity? Do they need heat? Do they need anything else? And then think how we can supply that. Which temperature level is must or do they use in their processes? How can we arrive this temperature level? For example, Benteler Steel Tube, at the moment they use a lot of natural gas, but of course they see that first, natural gas is not the best solution if you want to decarbonize your processes, and the other they see the price is rising for natural gas, so they think about other things. For them, the most easiest and most simple way is they just say, okay, give me any green gas and I can run my process as it is, and I just replace natural gas with the green gas, and then I'm fine. And you see the capacities built there, and we heard this wonderful lecture of Eva, Power to X. I mean, we have the capacity of renewables to produce renewable gas, hydrogen, or other fuels in the region, and there are ideas to do that, but maybe that's not the best way. Maybe we can rethink the process design. Maybe we can find some other places to reduce first the energy needs. And so the question that arises, what are the energy needs? Which energy carrier can we use? What is the resulting energy demand that needs to be or needs to come from the grid? Which conversion technologies do we use? And what about transport? Yeah, how to transport the hydrogen? How to transport the electricity? There we have also other issues because our infrastructure is not made for this change at the moment. If we change from natural gas to electricity, what about the grid? Is the grid still stable or not? And this is the point where we say, okay, if we want to decarbonize industry, we have to think industry in the integration in the regional energy systems. So what do we have, what do we need, and how can this match? Let's go to a more global view, and I show you the final energy demand worldwide. We have the transport, the dark blue part below, but I don't want to talk about transport today. Then we have the households, also mentioned in the last invited lectures, how to decarbonize our building sector. But the red part, you see, 30% of our total final energy demand is used in industry, and of that, 2/3 are used for process heat. If we step into this process heat, you see that more or less 50% of the process heat is used for high temperature applications, so above 500 degrees Celsius. But there is still a high share of process heat with lower temperatures, so 100, 200, 300, and for that we can find different solutions as for the high temperature heat demand. Then we can also have a look at the energy carriers, and unfortunately most process heat is processed by fossil fuels, so natural gas is the dominating energy carrier here. Then we have still coal, mostly in the steel industry, so steel producers. We have still oil there, and electricity, district heating, and renewable energy only counts for about 25%. And that needs to be changed if we want to decarbonize the industry and to reach our climate goals. Just one step back, why we have this high emissions in the value networks, and I think you all know it. So a big part of the greenhouse gas emissions in the value network are caused by burning fossil fuels. There are some processes which has process-related greenhouse gas emissions, for example, our nice cement industry, when they burn the clinker, but mostly the greenhouse gas emissions come from the use of fossil fuels somewhere in the value network. So it must not be in your own company, but if you buy steel, then somewhere in the upstream process they use fossil fuels to produce the steel. And in this project we started an approach. The project is called Climate Bowl. OWL is the region where we live, so you can make funny names out of it. And the funding agency just asked me, Climate Bowl, like Super Bowl? We do it. So sometimes a good name is a good thing. But we started to have a holistic view on this value network. So objective one was that we have a transparent monitoring of greenhouse gas emitters throughout the total value network. And then if we know where we have the emissions, where do they come from, then let's generate reduction actions to see where to reduce exactly the greenhouse gas emissions in our value network. We can see that, for example, in the wind turbines. We have the tower made of steel, we have our foundation, which is reinforced concrete, and I'm happy that the Danish manufacturer Vestas shares all his life cycle assessment of his wind turbines, so you can see all the data. And what you see is that most of the greenhouse gas emissions of renewable came from exactly the steel and the concrete used in manufacturing it. The operation is almost for free, as you all agreed. And that means if we once have sustainable materials, we will decrease the greenhouse gas emissions of renewable again and again. So there's a must that we have sustainable steel without any greenhouse gas emissions, because otherwise also our renewables are not free of greenhouse gas emissions. Okay, let's come back to to heating. And Neven, you showed the slide already, so there's no new information in there. We can do that with the natural gas boiler, then we have direct emissions, but we can also do that with the heat pump as a very efficient technology. I just assumed the COP of 3 here. But anyway, if we use heat pumps without changing our energy supply, so heat pump with coal power plants, that does not work. We just shift the emissions somewhere from the production of heat to the generation of electricity, and that's not the best idea. So we have to think the whole system and do the electrification of the heat supply with the heat pump, but also the decarbonization of our power system with renewables, most probably. And I just figured out here the direct greenhouse gas emissions. So of course, there are these embedded greenhouse gas emissions in the renewables, but let's assume that we can solve that once we have enough green steel and green materials. And then you see, we call it sector coupling, that we coupling the heating sector with the power sector, and we can decrease, that's even more important, we can decrease our primary energy demand, which is shown here. And you see, once we use renewables and a heat pump, we can decrease our power demand, primary energy demand a lot. Okay, so we have technologies that could decarbonize our heating system, but we talked a lot about efficiency as well. And of course, also in the industry, we have efficiency measures, and there are a lot of good papers discussing how we can do heat recovery, either directly to preheat any steam, shown here on the left-hand side with the example of electroplating, where you just use the waste heat to preheat a freshwater steam, and we can reduce our natural gas consumption, and we can also reduce our electricity consumption because, and that's the other point, we have a combined heat and cooling. So once we use waste heat, we need less, we don't have to remove all the heat with a cooling tower, with a chilling machine. That can save also electricity. And if we then implement a heat pump, that's shown here on the right-hand side, there you see that we can really save a lot of cooling energy. So instead of using a boiler and a compression chiller to remove the heat for cooling purpose and to produce heat for any heating applications, we can use a heat pump that removes, on the one hand, the heat, so it cools it down, the processes that need to be cooled, and on the other hand, it provides heat to the process, so we can reduce again our final energy consumption by integrating the heat pumps and doing this waste heat recovery and heat recovery. Okay, so we see there's a lot of different actions that we can make somewhere. We can talk about energy efficiency, we can talk about the change of energy supply, but how should it look in a holistic smart energy system design like? Yeah, and I just try to make a complex thing simple, so you lose a lot of information there, but that helps it to understand. And I have the example, because I hope that the air conditioner is on, and I'm very happy that it works. We have an energy demand, we have to remove the heat, for example, from this room. So we have an energy need to reach a certain temperature here on stage and in the room, and to provide fresh air to all of us. And therefore we use a technical system, an HVAC system with a chilling machine maybe, and we have a final energy demand. So somewhere we need electricity to run our technical solution. And at the end of the grid, there's an energy supply. And as mentioned before, we can look at different actions somewhere on these three areas. For example, to reduce the energy need, we can think about a better retrofitting of building, the correct setting of operation points. So is it really a good temperature here in the room, or could it be higher? So we say it could be not, for me. But to think how can we save or can we reduce our energy need? And then if we have the energy demand part, there we think about how to replace the technical system. Can we use a more efficient chilling machine, for example? Can we improve our ventilation system? And finally, on the energy supply, how to replace the fossil fuel power plants with the use of renewable energies, for example. How can we integrate cogeneration to regeneration? But once we talk about renewable energies, we also have to talk about how to overcome the problem with the fluctuations. So we need storages, we need demand response, and that causes other issues. From an energy efficient part of view, you would start on the left side with the energy we demand. So first reduce the energy needs, then the energy demand, and then think about the energy supply. But we don't have time to do it in that way, so we have to do actions on every part mentioned here. And this thing with the renewables changed a little bit the way of thinking, because now we do not talk about pure energy efficiency, but we talk about system efficiency. So the question is not, I mean, there's still the question to reduce the energy needs and to increase the energy efficiency, but there's also the question how to make best usage of any fluctuating renewable energies. And that can cause that we run systems in a not optimized way, not the best efficient way, but with renewable electricity. So the development of holistic smart energy system should be based on the energy needs. So we have to understand why we need energy. And then we see that renewables will change it, and we have other things coming up that are now very important to decarbonize all sectors. One is sector coupling, and the other is the flexibility to meet the fluctuating renewable power generation. So finally, you see system efficiency is a new objective of smart energy system, and that leads us to other questions. So what does flexibility mean, and how can we use flexibility? And we have done a study. Yeah, I hope the picture looks good. We have made a study about load shifting. You all know load shifting, and usually we just use electricity prices for load shifting and just argue that in times when the electricity price is low, we should increase our demand, and in times if the electricity price is high, we should reduce our demand. And the idea behind that, from a not economic point of view, but from an environmental point of view, is that if we have enough green electricity within the grid, the prices will be low, because the cheapest way to generate electricity is with renewables. And if we have not that much renewable in the system, then the price should be high because we run our gas turbines or something like that. And you see in this diagram, this is from the year 2018 in Germany, but we have done that also for other years and other areas with different energy mixes. And you see that it's true. So on the x-axis, you see the electricity price, and on the y-axis, you see the current emission factor, which of course is not constant over the whole year. Also, if we use it sometimes to calculate it. But we have times when there's enough renewable electricity that our emission factor is low, and we have times when there's almost no renewable electricity, and then we have high emission factors. And you see that there is, on the left side and the right side here, that there is, it works. So we have low electricity prices and low emissions, and we have high electricity prices and high emissions. But in between, I wouldn't say that there is a good correlation. So finally, we figured out that the correlation factor is something about 0.6 for this case, which does not mean that there is a strong correlation, and the only, or using only a price-based load shifting will not automatically lead to reduction of greenhouse gas emissions. And that's what we tested with the example of the food processing industry. They have a steam demand, and we say, okay, we can electrify a steam demand. That's possible. So we take an electric steam boiler, and we add a steam accumulator, so we have a storage capacity. And now we can play around and run the system in a more flexible way. And we use an optimization approach to do that. But we analyzed two different scenarios mainly. The one was, we called EBLS, emission-based load shifting, where the price signal is the emission factor. And then we have another scenario called PBLS, where the price, where the signal was the price, the electricity price. And you can see from the results that indeed, of course, if we use the electricity price, we can reduce our energy costs a lot. So down about, we can reduce it about minus 20%. But there was no change at all in the greenhouse gas emissions. And once we used this emission factor, we saw that we, of course, can reduce the greenhouse gas emissions, minus 8%, and there was still a decrease in the energy costs. And we analyzed that for this case, for this year, for this area, but also for other areas in Germany with different energy mixes in different years to see if it's really how it looks like, and it was the case for all analyzed settings. So the emission-based load shifting minimizes emissions while reducing costs, whereas price-based load shifting primarily brings economic benefit, but not automatically brings ecological benefit. And that's a big issue if we discuss demand response, and I'm pretty sure we need flexibility and demand response in our energy system once we change it to renewables. But then we should be sure that that we have the right mechanism and the right signal to do our demand response. And then there was another question about efficiency or flexibility, or both together. And we analyzed the same process shown on the last slide. We analyzed 4 scenarios. We have the reference case with the gas boiler, then we have an efficiency scenario with a very high temperature heat pump. Then we have a flexibility scenario with electric steam boiler, and then we have a hybrid one where we try to optimize both the use of the electric boiler as well as of the heat pump. And I'll show you the results. So the efficient scenario in this case was a really good scenario because we could reduce our greenhouse gas emissions a lot. And if we add flexibility, we could reduce it even more. If we use only the electric boiler, the electric steam generator in this case, there was no, so it was not optimized, it was just one, there was no big even increase in the greenhouse gas emissions. And if we have a look at the economic side of this analysis, we unfortunately saw that for the energy prices for 2021, where gas was still cheap and electricity was not that cheap, we saw that the natural gas boiler was more economic than the other solutions. If you do this analysis again with the prices we have now in Germany or even Europe, so the average prices, you will see that there is a different result because we have seen that there is a high sensitivity on the energy prices, and we have to reduce our electricity costs. The natural gas costs will automatically, I would say, increase. And then we see that there is a certain ratio between electricity price and natural gas price, where all these electrified ideas make an economic sense. Okay, I would like to come back to this map of Paderborn, because I promised Henrik that I will say something about district heating. And you see, as mentioned, we have our industry and we have high temperature heat industry, and they produce high temperature waste heat. And why do not, so we could use this high temperature waste heat as a source for district heating, as discussed a lot also in our scientific papers. And we actually do that in Paderborn. So we use the waste heat from ventilator steel tube to provide heat to some public buildings. And in the south, we started now a feasibility analysis. A feasibility analysis how we can use the waste heat from the cement production to run even other processes in other industries. So, but if we want to do that, you should always think about the case. So if the temperature, for example, in a ventilator steel tube has 400 degrees Celsius, maybe it's better to first run a process ventilator steel tube with low temperature needs before we go to the district heating system. And then, of course, there's the case, what should we do with our district heating once ventilator steel tube moves away or they change completely their production? So we have to think about robust systems as well. And there is some interesting works on how to change our production systems, because they will not be as they are at the moment for all time. And this is a project called Re2Ply, where we change a press hardening line. Usually you have a furnace to heat up your metal plates before you bring them to the press. But we can, of course, use an induction heating system. But that changes the way waste heat is produced, And that changes also the way we have an energy demand from the grid, because now instead of gas we need electricity, and we have to check if the infrastructure is already made for that, and how we can use, for example, also energy storages and renewable energies to run the process. And then I would like to show you also another way. We discussed to use data centers, the waste heat of data centers to run our district heatings. In Paderborn now we start another discussion. The discussion is to use data centers in wind turbines, so in the tower itself. Because there is an infrastructure, and the idea it's easier to bring the IT to energy than the energy to IT. So we have our infrastructure for the IT, and now we try to I mean, there are already data centers in the wind turbines. You see the picture here. And then we can run it in the wind turbines, and we can use it as a flexible load. So definitely not the data centers built in Frankfurt for trading. I think the bankers will kill me if I say you can just do your trading when there's enough wind in the system. But we have other computational tasks, yeah, like for example scientific modeling, which is critical, but not that critical, maybe, and we have a little bit of flexibility to run our computing tasks. And then there's another good thing if we build this, or maybe it's a bad thing, I don't know. We can discuss it later on. But once we build the data center in our wind turbine, we can use the tower itself as a for cooling. So we do not need any other cooling system. We try to use the tower, but that means that we cannot use the heat for district heating. So you see, there are always a lot of different sides to look at a problem, and definitely not all data centers will move to wind turbines, but some of them should. Okay, I think I have to come to an end. That's what we discussed today, what I've shown. The energy transition within the industry linked to the renewables, mainly wind and PV, and how to link also industry and business with the district heating system. But we have other issues, so we have to discuss super-regional aspects. Why should we use the energy in Paderborn? Maybe it's better to transport it anywhere else, in the rural area or to Bavaria, I don't know. But we can use it as well in our region. And we discussed about the industry and if we have high temperature applications. For that, there will be a use of any e-fuels or hydrogen, so we have to produce hydrogen. Then we have the district heating. There we can also use electrified things like heat pumps, and we have to discuss to which extent we use district heating, to which extent we have to use individual room heating, and how to combine both. We talked about load management and energy storages, and last but not least, we have this big part of new mobility, and I think it's not enough to just change a car with an electric car. I mean, we can do that and we do that, but that makes not sense. We have to change the way we use, or the way we demand for mobility, and to figure out different ways to move from one part to the other. Maybe car sharing is a good option, but once you use car sharing, you will use the cars, or they have another driving profile, and maybe that changes the vehicle-to-grid concepts. And at least we can also use hydrogen and e-fuels in the mobility sector. I hope not for car driving that much, but for aviation and shipping, that might be an option. And with that, I come to an end. So we see that renewable energy is a must for sustainable industry and commerce. And we saw that the energy efficient system design starts with understanding of energy needs. We should have not at least a holistic view on energy system, starting from the needs, but including also the demand and the supply. And the term efficiency switches from pure energy efficiency to more system thinking, to system efficiency, to think how to integrate the variable of fluctuating renewables in an efficient energy system. The electrification is a promising solution for decarbonizing process heat. The best way is to do it with direct electrification, but for these applications where we don't have the possibility or the technology yet for direct electrification, there might be a way of indirect electrification via e-fuels, but 4.16 euro cents. That's interesting. That's what I get for this lecture, no? Let's see. Not that much. Anyway, yeah, electrification. But we should also remember that there is no steady state of production or mobility. So once we try to solve this big issue of decarbonizing our energy needs will change over time. There are new technologies, there are new applications, and we have to build robust systems and robust integration that can work with changes as well. So flexibility enables a better usage of renewables, and to make all our system design also flexible might be a good way. And finally, industry and business models are subject to permanent change. That's what I've mentioned before. And with that, I hope I'm still good in time, and thank you for listening, and now let's have a wonderful discussion.
So, thank you, Professor Meschede, for your presentation. And now let's have from your side, possible question to Henning. Any question?
Hello, Michael Walmsley.
Oh, 2 questions at one time. That's good.
First you?
Yeah, Michael Walmsley from New Zealand. You didn't say too much about energy storage as another important part of the puzzle. You want to just sort of elaborate on what work you think needs to happen in that area?
The battery? No.
Well, I'm talking battery, thermal storage, all the other. I mean, it's a whole field.
Okay, so the whole part of energy storage is, yeah, I mean, we need them, definitely. So even if we make everything flexible, there's a big need for energy storages. And as you've seen in this example of making this steam process more flexible, there was a steam accumulator, which is a storage. There are plenty of batteries already installed in the system. We talked about vehicle to grid. And if we come back to industry, we see, so for example in Germany, a lot of industry companies buy batteries, but for peak shaving. So because we have to pay not only for our energy, but also for the peak load. And they say, okay, maybe it's more economic to buy a battery and to make this peak shaving. But you buy a battery, so you buy the whole resource just for one case and one purpose, which is not the best way. But once the battery is in the system, maybe we find other purposes to run the system. So we need storages in the whole energy system. We need batteries, we need flywheels because we lost a lot of our running turbines. But we have our hydro pumps, and we need heat storages as well. But they should be placed there where it makes sense and where we can make the best use of it to keep the resources as low as possible.
So we have another question.
Yes, my name is Petri Koua. I'm coming from University of Lappeenranta, University of Lappeenranta, yes, from Finland. And I would like to ask about your opinion about small-scale nuclear power plants. In Finland, we have had a lot of discussions about small-scale nuclear power plants providing district heat. So what is your opinion about that? Are they sustainable, or what do you think?
Okay, so I mean, in Germany we had a quite too long discussion about nuclear power, and finally we said, okay, we go out of nuclear power, and I see that there are a lot of other countries deciding to do nuclear power. And your question was if it's sustainable. I would say no. So we have lower greenhouse gas emissions than, for example, burning coal. Yeah, we had this discussion in Germany if it's better to run our nuclear power plants for a longer time instead of burning coal. But anyway, if we see the current state, we see that renewables, wind and PV is much cheaper and much more sustainable. And but anyway, as you see, I mean, there's a permanent change. Maybe once we have cheap nuclear energy and we find a good way to run the system safe and to deal with the waste. So we should be open to discuss it, but from my personal side, I doubt that it's that near in future, and I would say let's do what we have, and we have enough experience with PV system, with storage systems, and with wind turbines, and we can build an energy system based on that. That would be enough. And but of course, I mean, we are engineers and researchers. We should look also for other solutions and figure out if they're sustainable and good solutions or not. But definitely, I would say nuclear power is not in my focus research area. Welcome.
Other question? Never.
In the past, we were bringing energy from far away to have energy-intensive industries in industrial areas. But this energy was quite energy-dense, so it probably made sense. In future, we're going to also have quite a lot of production of energy somewhere away, because it will be much cheaper to produce wind and solar in Patagonia or Namibia or Australia. Are we going to stick to the same pattern of bringing energy to the industrial areas? But this energy is much less dense. First, it's electricity, so it has to be converted in some molecules. Hydrogen is difficult to transport. Then we already go into ammonia and methanol, or maybe even more into industrial finished goods. What is your take on that, coming from a significant industrial area?
Yeah, I hope that you asked this question or someone else, because there's another project I want to show you or want to explain to you. And first of all, I would like to disagree. So we bring out energy to the industry. We always have brought the industry to the energy. So the first was hydropower, and we built up the mills at the river. There was no way to bring the river to the mills. And then, for example, in Germany, we have this Ruhr area, which is there because there was a lot of coal. So, and then coal and especially oil changed this thinking, because now it was easy to bring the energy to the industry. And in some parts of Germany, they want to save it as it is, and that they have their industry and the energy should come to them. I think, we can discuss to bring hydrogen or any other e-fuels from Patagonia to Europe, and I think there will be a market for that, definitely. So, because we need the resources, and when it's cheap, and it seems to be cheaper to produce it in Patagonia or in Australia or somewhere else, or Namibia, we can bring it to Europe. But, and that's why I like this question, we can also think about to bring the industry back to the source of energy. So for the case of steel making in Germany, we import iron ore from Namibia, and now we want to import hydrogen also from Namibia. So we have two imports, and then we produce it in Germany. And unfortunately, as a German, I must say, maybe it's better to make it directly in Namibia. And there's a project from Paderborn, of course, but not from me, from an industry partner. And they said, okay, we have enough sun in Namibia, we have the iron ore over there, let's produce hydrogen, and then produce a kind of raw iron and transport this raw iron to Germany, and then we can use it to produce any steel and something like that. But a big part of the process chain could be moved somewhere else. And so from a just energy point of view, I would say that makes sense. But from an economic and political point of view, there are other issues to discuss that, and good ways why we shouldn't do that to have our economy running. But it's a possibility, yes. Okay.
Thank you. Here.
Thank you. This is Birol Kılkış from Ostim Technical University, Turkey. You have nicely showed us slide number 14, and had already mentioned that there are 3 stages: energy need, energy demand, and energy supply. And on the energy need side, you have also kindly mentioned retrofitting of buildings, passive houses, solar houses, nearly zero energy buildings, which minimize or reduce the demand or the load, heating or cooling. That's fine, but on the energy supply, you have also mentioned us that, which is, I agree completely, the waste heat of the industry or other sources must be utilized in the districts as much as possible. But I see a controversy there. If we keep retrofitting all the buildings, making them as an extreme all net zero energy, then we won't have the ability to utilize the waste heat, which is more or less low enthalpy energy sources. So there is an optimum which is dictated first by the fact that, yes, passive solar houses, insulation to a certain point is necessary to reduce the temperature in heating demand and to increase the cooling demand temperature so that we can directly use, or with minimum use of heat pumps, the waste heat. So this is the first step in optimization, but my question is how we can optimize it, on what basis? Could it be carbon dioxide emissions, economy, or what's your opinion? Thank you.
Yeah. Thanks for the question. Yeah, I mean, you mentioned it correctly. If we have an optimized, or the best way we can use, we first reduce our energy needs. Yeah, but to be honest, we have a big building stock which will not be insulated and retrofitted in the next years, but we have to deal with our greenhouse gas emissions. So I think that's the first point, that we don't have the time to do the things in the right way, and then we are all humans, and humans does not behave like researchers and engineers want them to behave, and we have a change of our houses, so we have to make robust systems that can work. We have to do a lot of insulation and retrofitting, but we have to think about to decarbonize the heat supply at the same time. And then you ask, what would be an optimized way? I would say that depends completely on the conditions and on the area where you are. We discussed now with some communities around our city how to do this heating planning for the communities. And it completely depends if we have a village with small single-family houses with owners of their own house. Maybe you can convince them more to invest in retrofitting measures. But if you are once in the city where you have the big multi-family houses and there's an investor, and unfortunately the investor does not care about any energy savings, maybe it's better to say, okay, you don't care about energy savings, but we care about your energy supply, and we will supply this house with district heating from any waste heat source, any renewable curtailment wind energy, something like that. And then he says, okay, I don't have to care about insulation, but then we will push him again and again, and at some time he has to do it. But we have a decarbonized multifamily house, which is better for us and for the climate. Does it answer your question?
Yes, absolutely. Thank you
Perfect, thanks.
I also have a question for you.
Okay.
What is your idea in particular for solar thermal application? For district heating, for example, 5th generation district heating, but also for starting for 3rd. And what about for industrial processes, hydrogen, green hydrogen included? So, what is your idea about solar thermal?
Yes, it's difficult to. No, it's simple to answer. Because if we build solar thermal plants somewhere, they are more or less fixed to the operation and to the use that is there all the time. PV might be a little bit more flexible because we can transport power to other areas. I like solar thermal a lot, and I think it's a good way to produce low temperature heat. But if you collect all the heat from the industry, business, data centers, and so on, the amount of needed low temperature heating will not that high, unfortunately, I guess. So, yeah, maybe if we have limited space, it's better to install PV systems instead of solar thermal systems. But there will be applications of solar thermal as well. And so the one is in district heating, and that's one option. And as you mentioned, in industry, but the industry, I would say they look more for PV. So if they have the chance to build something on their rooftops, they will look more into PV with a heat pump, maybe instead of the solar thermal system, which is then fixed to one setting point.
Okay. We have more time for questions, so here, please.
Hi, I'm Luca Cimino from University of Napoli Federico II. Thank you for your brilliant presentation. I would like to know your opinion about the possibility of integration of biomass gasification in the whole process for producing like high temperature syngas, which can be used in the processes, industrial processes at a very high temperature, by also maybe exploiting some industrial wastes for gasification process. Thank you.
Okay, so biomass is very good source of renewable. Let's assume it's sustainable, the biomass, but then it's a very good source of renewable. But unfortunately, we don't have that amount of biomass to run all the processes. So we should carefully look at the processes that should be run with biomass. And in my opinion, we should electrify all the low temperature heat processes as much as possible. So first reduce the waste heat and then electrify them. And then there are still processes where we have to think about other solutions for high temperature. And if we can use biomass, it's a good solution if we have enough sustainable biomass there. Or we use hydrogen and other e-fuels, and maybe there are also some processes where we can burn waste. It's not that sustainable, but for example, in the cement production, we could burn waste because we have to remove the greenhouse gas emissions anyway. So maybe that's the best place to do it. And yeah, so we should use the biomass, the sustainable part of biomass, and I would prefer to use it in the industry instead of using it at home for 60 degree Celsius warm water. We have better solutions for that. Yeah.
Thank you so much.
We have time for more questions, so please.
Robert Weiss from VTT Technical Research Center of Finland. We have a huge gas grid, and even to the distribution in Central Europe, everywhere, gas grid, Germany, half of the households are heated with gas. There will be a lot of stranded assets, maybe shifting to heat pumps. How do you see the future of the gas grid, including the gas distribution grid? Can it be a balancing factor or something, or is it just stranded?
So to give you a short answer, all the utilities I discussed with, so we call them Stadtwerke, the local utilities, they don't see the gas grid anymore as an asset for them. They just say, okay, let's go to district heating or to electrified system, but not in the distribution network. It changes when it comes to industry. There might be, so if you have a big demand for gas in the industry, there might be a chance to still run the gas network. And then if you have this one customer, there might be other ways to link it to some households as well, but not that much. I would say it's more or less a stranded asset, and they switch to electrified solutions or district heating.
Another question here? Please, the microphone. Thank you.
Thank you for your presentation. Goran Kraljic, University of Zagreb. On Monday we were discussing energy communities, and also Professor Wimsley showed us that in New Zealand they are thinking about energy communities of industry and surrounding areas. So are you facing this, or do you have any example that they started to do that in Germany or in your region?
Yes, we have some energy communities, and what I've shown on one of the last slides, this how to link different industry sites and to make a waste heat cascade could be something like an energy community as well, but they are not isolated and not self-sufficient. So I don't think that's a good way to handle this problem. So we have to think in a bigger scale, and to see the transport from energy between energy communities as a chance and opportunity. But anyway, I mean, the energy system in Europe was made top-down, if we see the power system. And maybe we see that energy communities and the bottom-up approach might be more resilient and more robust. So that's really difficult to say, and I like this idea of energy communities. They are not isolated, but they communicate with each other and share, or can work as a flexible customer in the energy system. But also the community might not be fixed, so sometimes you merge communities, sometimes you divide them. That will be really interesting to see how we can change national or supranational power system like it is in Europe, and to make this approach of energy communities, flexible energy communities over the time, happen in that, and that would be a benefit in the robustness, the resilience, and of course in the usage of renewables.
Some more questions? Here.
It's getting warm here.
And then there.
Thank you for very inspiring presentation. Zdravko Krovanja, University of Maribor, Slovenia. The question is the following one. We don't want to install new systems in the way to compromise biodiversity, okay? And then the question, in your case in Paderborn, do you have any figure how much additional land you are using for installing wind turbines and PV stations? And how can that be avoided or reduced?
Okay. So you mean that we should save our land? So that's how it looks in Germany. We just put the wind turbines, and then we have the agriculture around it. And it's not that much land that is used for wind turbines, because hopefully they're high. For ground-mounted PV system, it's another discussion. We think now, or start thinking about agri-PV, so to use the same area for PV, but also for agriculture, but then you build up the PV plants in 4 meter high, which means that you need more material for the construction, but you can use the area for different purposes. And but I think to put wind turbines somewhere in the agriculture and farmland is not the problem. It's more a case about acceptance of the population, and there we have very good experience in Paderborn, So I mean, there are really a lot of wind turbines. Yeah, you stand somewhere and you see all around you see wind turbines, and you can increase your acceptance once the people see that they get money from the wind turbines. So, and the communities. So the community has a budget of about that from the government, and then they have a budget from the wind turbines, which is about that. And then you can completely convince the people to build more and more wind turbines because they see that there's a profit. They have cheap tariffs because there was some utility, some sailor, they just say, okay, we can sell you the electricity for a very low price, so they have one profit. Then they have that the community is growing, and there's no big resistance against wind turbines in that region right now. So they fought for 30 years, and now it's done, and now they say, okay, let's build more and more because we have the profit, and we want to build another one and to run the system. And for PV, to come back to your question about the area, I think there is still space in Paderborn. So I showed you that we are on rank 1, but whenever I look out of the window and see all the rooftops, I would say, okay, we are rank, I don't know, 200 or something like that. There's still enough roof area and parking spaces and so on, and then the facades. But area is a critical thing. We have to consider that here.
Yeah, thank you very much.
Other questions? Goran.
I just would like to comment this very nice photo where you show the importance of everything. So you have food, energy, and water nexus here, you know, so it's everything there. Thank you.
Perfect, yeah. I can send it to you. It's made by me. No, it's made by one of my employees. We have to drive with the car, and I just say, stop here, we have to make a picture for the presentation in Dubrovnik.
Just a short comment on this picture also. We see high towers and a free space. Why don't we put PVs or PVTs that can track the sun in both ways and with minimum shading effect on the land? So why do we waste these towers with just supporting the turbine, but the rest is useless?
No, there's farming land between the towers, so there's still farming land, and unfortunately, you cannot see it on this picture, but there's still, so some of the wind parks are really old, and they have small wind turbines, about 70 meters high, and now they build them up to 150 and 200, and they just decided to keep the old ones in place because they do not disturb the new ones because they are too high for that. So it's really interesting if you drive through the region to see that there are wind turbines for the last 20 years.
I understand, maybe I just misexpressed. What I mean is, why don't we mount on the tower?
On the tower?
Yes.
That's a good question. So I don't have any answer, but I've never thought about that idea, yeah. That's quite good.
Sure.
Other questions? Okay. We should finish. Thank you everybody for coming, and thank you to Professor Meschede for his lecture. Now we have lunchtime. Thank you, and see you again.